Here's an example of manipulating thermochemical equations. So I have three equations that have been given, and this is my target equation. Copper plus half of oxygen gas gives you copper 2 oxide. And we're looking for the heat of formation of copper 2 oxide. So how do I use these equations so that I will add up and cancel things out so I'll get only this at the end? Well, first of all, there's some strategies that you can use how to manipulate the equations, and the first one is to get the products and reactants on the correct side. So let's look at our given equations, and we have copper on the left hand side, and the first equation has copper on the left hand side, so that seems good. What else? I have copper 2 oxide on the right hand side, and there's this third equation has copper 2 oxide on the right hand side. So we're going to leave those equations as they are and bring them down and now have them down here. So this is where we're going to work. We're not going to work with the format up there. If we need to do anything, it'll be down here. Okay, so what's the next strategy? Cancel any compounds that are not in the target equation. So I have copper plus half an oxygen plus copper 2 oxide. Let's look here. I have this sulfur equation here, and I have sulfur dioxide here. So if you look, I've got sulfur dioxide on this side, on the right hand side. So it seems that I don't really want sulfur dioxide. So that's on the right hand side of my given equation and also on the right hand side of one of my equations. So I really don't want them to be on the same side because I don't want them. I want to then reverse this second equation so it looks like this, so that the sulfur dioxide on the right hand side in this equation will be canceled out there. So let's see what happens. I put these two on opposite sides, so I reverse this equation, and also when I reverse equations I have to do everything I have done to the delta H, so that's that third strategy. So it was reversed up here, and so the sign of the delta H is also reversed. Okay, so I did that to cancel out the SO2s. Let's see what else I can do to cancel. And let's see, sulfur is not in my target equation, and copper 2, this copper sulfide, copper 1 sulfide, it's also not in my target equation, so they cancel out. The sulfur also cancels out, and so those compounds are not in my target equation. I think I've canceled everything out. And then what I get left over is, now I have 2 coppers and I have 2 oxygens on the left hand side and 1 oxygen on the right hand side, so I really only get 1 oxygen over on the left hand side, so that kind of cancels out too. And then I have my 2 copper oxides, and then if I add up all those numbers I get negative 310 kilojoules. Now it looks like I'm done. However, the original target equation says for 1 mole of copper solid, and I have 2 moles of copper solid, so really the next thing I do is divide everything by 2, because that's the only difference between my target equation and what I ended up with. So I divide everything by 2 and I get my target equation, and if I divide this heat by 2 I also get the heat of formation of copper 2 oxide, which is what the question asked me.